Hello, in this video I will show you what is PWM. You are going to understand what is PWM with Arduino. We are going to see a PC oscilloscope that I'm going to use. And the main reason I have a PC oscilloscope is because I'm doing a screencast and the PC oscilloscope shows the signal in the computer screen. Then we are going to see what is pulse width modulation. I will do a circuit that is going to be used to visualize the PWM signals with the PC oscilloscope. So what is pulse width modulation? You can think it's a voltage versus time signal. That's how it's called in electronics. In math, we just call it a periodic function in time. I'm showing over here that 50% of the time, the voltage is, let's say, 5 volts. 50% of the time, the signal is 0 volts. And it repeats like a periodic function in time. So what is a signal? A signal is a periodic function of time. And what is pulse width modulation? Usually is a signal that is a square on, off, on, off, on, off. 50% of the time is 5 volts and 50% of the time is 0 volts. And this is an example of 10. I'm only putting 2 peaks, but this repeats over and over. And I offset the 0. I offset the 0 for visualization purposes. And 10% of the time is 5 volts, 90% of the time is 0 volts. And 0 duty cycle is 0 volts all the time, or constant, no voltage. And this is supposed to say 100% duty cycle. Let me change it. This is 100%. 100% duty cycle is DC. Is no, the voltage is not changing in time. Is, you could think is direct current. The voltage is always, in the case of Arduino that we are going to be using, 5 volts. Alright, this is the circuit that we are going to be doing. We are going to use an Arduino Nano, as you can see over here. The signals are going to be on channel 6. Channel 6. So channel 1 on the oscilloscope is going to be on pin 6. And channel 2 of the oscilloscope is going to be on pin 3. Then we are going to use these pods to manage the PWM signals, and these pods are going to be connected to the ground is the one on the left. And you could fast forward this part of the video. And then this is go to 5 volts. And 5 volts. I try to use red for 5 volts and black for ground. And now then this is 5, so I go over here and put over here, and just put it like this, and this goes over here, and then ground to ground. So I'm going to pause the video and continue the circuit, and then I will show you the final product. Alright, this is the circuit as it's going to be. The first thing to understand is that, okay, this is the circuit that we are going to use to understand PWM. The first thing to understand is that in a microcontroller, everything is transformed into integers. And for example, a signal from 0 to 5 volts is what they call, engineers call analog signals. But you are going to get or read from the computer a number from 0 to 1023. Remember that 2 to the 10th is 1024. So anytime I say analog signal, I means physically a voltage between 0 and 5, and in the computer, if we get the value from the using the software, we are going to get a number from 0 to 1023 volts. That's the first thing to keep in mind. However, when you are doing the pulse width modulation, like I show you, they don't use the number from 0 to 100%. Instead, they use numbers from 0 to 255. Meaning 0% and 100% is 255. So when we put the signal using the potentiometer, what the potentiometer does is that in the white leg we get a fraction of 5 volts. So between the legs on that side of the pop, you have 5 volts. And it's a variable resistor, there is a voltage divider, there is a separate video for that. Then the white leg or the middle leg that I have to analog 0 and the other one to analog 2 to analog 1, they give you a voltage between 0 and 5. So the microcontroller is going to give us a number between 0 and 1023. Then we are going to change that number, scale that number from 0 to 255, and that is the PWM signal that we are going to put on the scope. The Arduino has 2 frequencies. We are going to see what those 2 frequencies are. The frequency at pin 6, I think is 890 kilohertz, and the frequency on pin 3 is 470 kilohertz, and those are the signals that we are going to see on the scope. I prefer to use this software for showing the circuit, but once I put the document camera, what you are going to see in the document camera is the PC oscilloscope and this circuit. Okay, this is the Arduino with the circuit that I show you. These are the 2 pots connected to analog 0 and analog 1. What the pot does is a voltage divider. It gives you a fraction of 5 volts. We are going to see this on the serial monitor. We are not using the PC oscilloscope yet. So we are going to serial begin 9600. It's just to show the screen with the values in the computer. That's what the serial begin 9600 is. And we are going to use A0 as an output. Input. We are going to get the data into the A0. We are now going to read the data from A0 and A1. And we are going to display over here serial print, and we are going to put A0 just like this. And then we are going to do analog read A0. Let's do a print line do a enter after, and then we are going to do the same thing for A1. And we save the code. And so let's go. Okay, so I add a delay of half a second. Delay take milliseconds, so 500 milliseconds is a second. So it's going to read the values of analog 0 and analog 1 and put it on the screen. I open the serial monitor, and as you can see, I'm reading the maximum. That means that I put the ground of the pot. I put it at 5 volts, and the 5 volts to the ground. So let me switch that. And let me pause the video and fix that, because the pots are all the way to the left. It's supposed to read 0, and it's reading the maximum. So I changed the legs on the Arduino to the one on the left supposed to be the ground, the one on the right supposed to be the 5 volts. Now I open the serial monitor. As you can see, A0 and A1 are reading 0 volts because it's all the way to the left. And now I'm increasing A0 all the way to the other end. And you see that it's a maximum of 1023. Now I'm doing the same thing on the other pot. I increase, and you see, and that is what is called an analog signal. Is a voltage between 0 and 5 that is transformed from 0 to 1023. That is 1042 to the 10th power. Okay, so this part of the circuit is working, and now we are going to transform this signal into a signal from 0 to 255. So let me put this half all the way to 0 again. Pause the video. Now I add these 2 byte variables. The reason I'm using a byte, because a byte is a number from 0 to 255, 256, and it's going to be the channel duty cycle. So once I read the values over here, I will change it to these values. So instead of putting this over here, and this is going to be this, and then times 255 over 1023, and then I do the same for the other one. And now the duty cycle is a number between 0 and 255. And I'm going to put these values over here on the output now. And this is duty cycle 1 and duty cycle 2. Alright, as you can see, the duty cycle that I'm going to be used on channel 1 and channel 2 are 0, and if I go all the way to the end, I get 255 on channel 1, that's 100% duty cycle, or a DC signal of 5 volts. Now I increase the duty cycle in channel 2 all the way to 255. And everything is working, so now we are going to output the PWM signals on channel 3 and channel 5. In this case, I prefer to use the define function like it is in C. That means that this 3 is in this text. So anytime that in the code is the text channel 1 is going to be 3. And that is done before compiling. It's more like if you use define, it's more like a text thing. Now I'm going to copy this, and this is going to be channel 1 output, and channel 2 output, and I'm going to put this into do analog write on channel 1, and I pass the duty cycle on channel 1. So it's going to be PWM signal at channel 1. Similarly, on channel 2, and put a couple of spaces over here so the code looks cleaner. And these are the signals that we are going to read for channel 1 in the PC oscilloscope. And these are the two signals that we are going to do. And what it means, depending on the duty cycle, you are going to see the square signal 50, 50, 50, and the percentage of the time that is at 5 volts depends on the duty cycle, as I previously explained. Now I'm going to execute the code, transfer the code into Arduino, and then we are going to see this in the oscilloscope. Okay, I opened the PC oscilloscope signal. As you can see, the blue and the yellow signals over here in the scope. So for testing purposes, the yellow one, I'm going to remove the yellow one. There is nothing there. I haven't transferred the code to the Arduino yet. And if I put on 5 volts, you see that is working. I have that on channel 5. And the blue, I put it on 5 volts, switch it to 5 volts. You see it working. And that is 3. I think the only thing I need to put more voltage over here. 1 volt per division. I prefer 500. And here 500 millivolts per division. And now let's see. I think that's too much. So let's do 1 volt per third division, and on the yellow channel 1 volt third division. And let's see, 5, 5, and 5, 5. Okay, so the signal is working. Now I'm going to transfer the code to Arduino. I transfer the code to Arduino, Ctrl+Shift+M, open the serial monitor, move it to here, reduce the size, and go all the way to 0. I have no signal. And I open the scope. You see nothing there. I'm going to increase the yellow one first. I have the pins backwards. So let me go and fix that in the code. Channel 1 is 5, channel 2 is 3. And let's go back to 0. The monitor, see, everything is 0. Open the oscilloscope. I minimize this so I can have both of them. And the serial monitor. Reduce this on here. Webcam over here. The serial monitor. Let me pause the video. Alright, so now it is how I want to show it. Let me just increase this over here. And you see the webcam, the serial monitor, and there is no signal because 0 duty cycle means 0 volts. So I'm going to increase channel 1. As you see, that's about, it's not 13%, remember 100% is 255, so I will go to 50%, that is 127. That's 255, 100%. I have a delay of half a second, so I need to go really slow. So okay, let me. And now the other signal. It jumps right there because I'm using byte instead of integer. Alright, I was having the numbers were fluctuating from 0 to 200 and something, so this division, if I put a decimal point, is float, and then I cast it as an integer and made the values integers instead of byte, and now I changed from 0 to 127. That's what I wanted to put. That is 50% duty cycle. The other thing I did is I changed the delay to 15 milliseconds. Now you can see the scope over here. That's 50% duty cycle. Let me move the channel 1, the other one down here for visualization purposes. and I will increase and open the monitor so you can see now channel all the way to 50% duty cycle. The reason is different is because the scale are different. The time scales are different. So as you can see at the bottom, let me remove this over here. As you can see over here at the bottom of the screen, the frequency of channel 1 is 975 and the frequency on channel 2 is 489, and that's what is very close to the specs of the Arduino. So let me go back to a small duty cycle here and here, and I wish I could put the same scale on both of them. I don't know how to do that yet. So these are the two signals. The reason is that the time scale in the manual control over here, no, don't see the option to change the time scale. Signal. Okay. And these are the two. Oh, of course not. Of course not. This, the blue one, is half the frequency of the top one. Of course it has to be like that because the frequencies are different. 975 for the yellow one hertz and 489 for the blue one. Yes, the frequencies are different. That's why you see it like that. The slow one is on channel 3 at 490 hertz, and the fast one is the one the channel 1 on the scope, which is at 975 hertz, is what I'm measuring with the PC oscilloscope. So what is PWM? It's a periodic function in time at some frequency, but the percentage of the wave that is on, or 5 volts, is depending on the duty cycle. So this is 50% duty cycle, about 5%, 50%, and close to 100% duty cycle. And the frequency could be anything that they choose. And this is what is PWM, is very useful in microcontrollers electronics. Alright, so this is the summary understanding pulse width modulation with Arduino. As we saw that we use the PC oscilloscope because I can do a screencast and it's easier for me to show it. We saw what is pulse width modulation is a periodic signal in time, and the percentage of the time that the signal has some voltage in Arduino 5 volts is what is called the duty cycle. So this is 10 50% duty cycle, this is about 10% duty cycle, 0 duty cycle, means no signal, and 100% duty cycle, you can see it like a DC signal. This is the circuit that we used. We used the 2 pots to manage the duty cycle, and we use channel 5, pin 5, and pin 3. Pin 5 is about 900 Hertz, and pin 3 is about 500 Hertz. Excuse me, PWM signals that you see in the Arduino. Now this is the 2 signals on both channels, and on the bottom I maximize the peak-to-peak frequency. As you can see, is not exactly 5 volts, and the frequencies are measured with this scope are 975 and 489. So this concludes the video of what is PWM. We visualize the signals. In further videos you are going to see how this is used in microcontroller electronics. Have a good day.